Alright, today we actually have tube time because we have tube stuff. What do we have tube time?
We have a tube tester.
TV-2B slash military.
Very military.
Very great. Ooh,
Words cannot describe the smell.
yeah, it smells. And it's very typical of tube equipment that has this. So I don't know what it is. MacLeod, can you, well, what do you think? Can you describe
It's
it?
like bakelite and rubber and hot glass with dust on it, and maybe a little bit of lubricant in there.
A hint of underbrush and some dark berries. So look at that beauty. And what I like in this one is that it gives you a meter for every voltage on your plates, right? On your grids and plates.
All the important voltages. Yeah.
Right, and then you can put them any way you want. So you can test any tube if you have the spec of the tube, even if it's not on the rollers, you can have.
So these knobs take the critical connections and wire them to pins on the tube sockets.
Yes.
So you can map it however you want.
Mm-hmm. And then you can choose whatever voltage you put everywhere. If you have a tube that's known, you just set it from the chart. But you can test any tube, really, by using the switches and the gauges. So you should have a few tubes in it, not that much. It's really basically 3 tubes for the power supplies.
And they're diodes, so pretty straightforward.
Right. And one is mercury, so it should light up.
It's mostly wiring and probably some wafer switches.
Yeah, so bad contacts could be a problem. Let's open it up. From what I gather, I'm not super knowledgeable, but maybe since you've done more tube stuff, you know more, but it's a tester that was designed by Hickok and then made by another company for the military or something like that. So it has some Hickok genes, but it's not a Hickok proper.
It's got all the sockets on it too. Sub-miniature 7-pin, all the inline. So those are for the real tiny tubes.
Oh, I hadn't seen that. Right over here. Can you point at it?
Here's our sub-miniature 7-pin and
yeah.
then our sub-miniature 8-pin over here.
Oh, more than witchcraft. Okay. More screws.
Did we miss a screw?
Probably. Wait,
This two maybe?
We remove 14 screws, lift the panel in the chassis from the case by handles mounted on the panel. I'm not getting, oh, it is really sealed, okay. Seal breaker.
Pry bar for prying eyes.
I did not expect it to turning into an auto mechanic experience. Okay, breaking it free.
Oh, there we go.
Oh, okay, that works. Oh, beautiful. I see tube. Oh man, it smells even stronger. Ooh, wow, it's clean.
Wow.
It's clean as a whistle. Look at that wiring. It's like...
It's colorful.
Yeah, it's like... Did they think they were in the 70s or something?
Every single wire has a little ferrite bead on it.
Yes. So this, I read, is a after-the-fact thing. It's an improvement.
Okay.
It's an update. So we have the caps 59. Okay, this is from 1959. And
there's the resistor board. Wow.
Resistor board. Okay, I'm told it doesn't work. I'm told the main meter doesn't work. We probably need to check the resistors, see if they have moved or not.
Oh, these are spare tubes. Look, see, they're in a rubber grommet.
Oh!
And they're set up so you can just hot swap them in.
Awesome. Ooh, our meter that doesn't work unfortunately says sealed, do not open.
But since when has that stopped us?
Well, we'll have to repair it, so we don't have much of a choice. So this tube appears to be a spare, and this tube appears to be a spare. And then the whole machine is just those three tubes, and lots of wiring, and a few caps, and lots of magnetics. Very cool. Okay, let's see how we're going to measure this. So we'll use a mobile tester. Want to try with a 2000. 1.9 millifarad.
Again, there you go.
70, and it's supposed to be
50, I think.
50.
Yeah.
And I should have
It should be 10,
10 and
each.
10.
Yeah.
16
Yeah.
and 15. So they have kept their capacitance.
That's really good.
That's
That's like right on. I mean, they might have some extra leakage
yeah.
current, right?
So we'll
That
have to
should
bring it.
settle down.
We should have to bring it slowly on the variant. So this is what 4901 490. No, 4.9 kilo ohms. Yeah, that's correct. 50000. 50k. 50k, right on the money. 105, right in the middle. For 38, I'm measuring 3826.
Yeah, this is very close.
You just do a sample of the carbon resistors. If you find that some of them are right in the range, usually none of the others will have moved. If you find that some of them have moved, usually all will have moved.
Right.
So I think we'll probably have the military kind of resistors that are better than the average consumer ones. So I found one potential slight problem. Is this contact, which one was it? This one is not touching this fellow here. That is lifted. Okay, so we have to repair that. So it's not 100% perfect. So it looks like our contact is really screwed up here. It's been completely moved out of position. Yeah, so pushing down on it just didn't do anything. So this is a little bit worse than we thought. The contact might actually have been broken on the underside, which caused it to collide with the rotating things and then to get bent. So it's a third degree failure. We might need to remove the wafer, which is tough. Here we're almost there, but there are some wires that are under tension. Just try to see if just soldering the taut wires will be enough to flip that board. It's the usual stuff, right? You'd think it would be super simple, you'll be done in 5 minutes, and then no such luck. Oh, and they wrapped it around like 10 times. You can always cut the loop and do it. There you go. Let's see if that benefits us. So that's the white, and that's the green. Oh yes, that gets us one more step until the next wire. This is noodle wiring to the max. The epitome of spaghetti wiring. Oh gee wee. One blue. Almost. Two blues. Alright. Aha! So here's where I am at. I have removed a few more wires to push this backwards. I have moved that part of chassis forward so I have good access to this. And that's the contact that's broken. It's that guy right here. And no amount of pushing it down is going to work, of course. So we need to remove the wafer. It's 12 connections. These are the wires that I removed from the main board, so I still know where they are. And this is my wafer connections with the mark, so I can retime it correctly. And we have 6 wires and 6 connections to the wafer under it. Alright, so I'll probably not film the desoldering because I need full access. I can't have the camera in the way. Alright, it took a while, but I desoldered my wafer. So now I should be able to extract it. Whew. Then I have marked the orientation. Yeah, I got it. Right. Wafer is out. We can go under the microscope and repair it. Aha! And under the microscope you can right away see what went wrong and why no amount of pushing would work, because the pincer has just jumped over the track. The lower tongue should be underneath the track. So I don't know how it jumped off. Each contact, there is a top and a bottom, and each is a pincer. It's actually one piece of metal that comes, is bent around, and comes back down. Managed to separate the two layers. Now I need to cut it and see if I can rotate the top, access the bottom, straighten the bottom, put the top back. So far I was able to cut the back of the fold and move the top contact with respect to the bottom contact, and it's hard to see in the picture, but the bottom contact is at 45-degree angle, completely bent. So I need to find a way to unbend this, make it flat again, and go under this lip. Okay, I wish I had a trinocular so I could see what I'm doing, but I managed to get the bottom contact flattened out. And now I need to slide it. So you'll see that we've progressed. I have the bottom contact now flattened and slid underneath the slider, and I have to put the top contact so it pinches it, which is going to be another interesting challenge. You really need a binocular for this sort of work because you need depth perception. One of those microscope cameras won't do it. So I arrive at the point where the top of the pincer is totally normal now. The bottom, in order for it not to catch, I had to push it down and it's not making contact. So I have half a contact, which is not ideal, but at least will work. I can test it with an ohm meter, see if that works. Yep. Okay. It works. Only from the contact in the top, but that's enough to get us going. Right, so I put back the wafer on my little mark, and that aligns with another mark that's over here. And now I use my handy dandy map of the wiring, so I put the right wires at the right place. All right. Whew. So while we are in there, we need to change these wires because they were pretty crusty outside. Yeah, these have turned totally solid here. Alright, got it. Right, fortunately we do have high voltage cable left from our CRT episode. So we need something of this length. Alright, there we go. Do the big squeeze. And here we go. First wire. I mean, whoever invented this, I hope he goes in engineering hell. There we go. Too short. Better. Okay, so repair number 2 completed. Man, the tube stuff is so heavy. It is actually physically demanding. Whew. It's exhausting mentally and physically. Gives another new meaning to boat anchor. Okay, success. So now we need to resolder all our wires. Handy dandy wiring chart tells me the black and white go here. Nice and tight. Green and white goes here. Then white goes here. Alright. And then two blues go down there. Alright. Okay. Done. Next one, repair 3. This bit of the board was broken. And there was a previous repair, but that failed. So that's crying out loud for JB Weld. This way. It will not fail. Okay, third repair. So I was told the mirror doesn't work, and I'm going to test it with an ohm meter. It's 100 microamps. It does work. That doesn't seem to be the problem. So there might be another fault in the machine that prevents it from working. But it's not the meter. Right, so while the glue is drying, I'm going to do a bit of cleaning. Actually, let's do this properly. So many buttons. Okay, so that's not too bad. I need to get the switches cleaned. There we go. Much better. I'm going to use a little bit of auto polish, paint polish to something not working here. One more fault. Okay, so that one is in need of dielectric grease. Ah, much better. That's all shiny and beautiful. Done. Okay, I think we're sort of ready to go. I put a tube on there, it's a 25L6, that's a pentode. I found it over here. We have to read the settings there and then go for it. Gain, function, test. So we're in test. Settings for the filament is 7 and 2. Those are the pins for the filament. 5 is the grid. 3 is the plate. And 4 is the screen. The voltage is 26.5. And we probably will have to reduce it to 25 because it's 25L6. Bias range 10, I'm already there. Plate screen range J, I'm already in J. Transconductor signal range B. Plate at 200 volts, so I will have to adjust it to 200 volt with that knob. Bias 8, I'll have to adjust it here to 8. Okay, then we adjust all these, alright? The signal, red line, then we'll have to adjust it to the red line. So we're all set to turn it on, and I have a variac over here. Control the value of filament range on column. Insert tube in proper socket. Oh, you insert the tube once you have set the range of the filament. Okay, remove this. Turn the thing on and see if anything happens. No pilot light, no nothing. Oh, I didn't turn it on. That might be my problem. Okay, try it again. On. Any sign of life? I do not see any voltages. My rectifier didn't turn on. We got absolutely nothing. No filament voltage. Not encouraging. Fuses look good. Fuses to amp. Oh, 3 amp. Yeah, that's what it's supposed to be. So fuses are good. Should be filament voltage. I should have something past the fuse. It should illuminate the neon bulb, and then I should get some voltage at the other side of the transformer. Okay, we're just checking the power entry, and this is no good. There is no insulation on the wire, so that's no good at all.
Moments later.
Alright, we have a new power cable, which, by the way, allowed me to repair one more of the features of this instrument. They thought about everything, so that's how it should work, and you couldn't do it with the cable before because it was too short. But you have a spot here that's connected to nothing. It's just to hold the plug when it's all coiled up. Okay, 110 volts over here. Off. On, 110 volts. There. 115, okay, we're getting better. So I have power to the input of the transformer. I have the wiring of the transformer right here. So 1 and 2 is the filament input. 88 volts. I guess that's correct because there is a resistance with the filament. So I should have filament voltage right now. I do have 25 volts, okay. Ah, here we go. Light of happiness. Filament voltage. I have plate voltage. Bias is coming. Oh, with live screen voltage. Signal. Oh, we have filament voltages, and it switches ranges automatically, and then with the fine adjust here, that's working. Bias here, same thing. It's oops. Or AB must be for a different thing, and I can adjust it. Perfect. Plate. I have plate voltage. Screen. I have screen voltage and some range. I have some signal. Alright, so all my dials are here. Because I have no tube, I have 0 here. Actually, this thing is not zeroed for some reason. And now I need to adjust plate to 200 volts. Plate to 200 volts. There you go. Screen to 115. What? It's graduated in quarters? 125? No. Gee. We need to adjust the filament voltage to 25. Right. Okay, man, so which Which of these scales am I looking at? Oh, but I'm not correct at all. I should be at 26. And I need to be at 25 right there. So I was lamenting that I could not get at 0, but I can. Alright. And I insert the tube while the thing is on. Alright. I don't have the filament continuity, so my neon might be bad, but the tube is warming up. So then I do a short test. I put this to line position and I go here, 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 here. But since my filament thing is not working, it's not going to give me an indication anyhow. Let's go to the next step here. So reset plate to voltage listed. So we go back here, put it back at 200 volts. All right. Set GM signal range to F and depress P4 and reset the control as shown in roll chart. Signal range to F. That might be a zeroing thing. Depress P4. I think that's probably to get that to 0. You release it. Return signal range to B. And then you depress F4, and now I'm going to measure my tube. Haha! And it is a very good tube. It's at 125%. We just tested our first tube. Okay. This is a bit complicated, but success! One tube going. Excellent. I still have one fault. I still have the neon lamp not working. So let me see if I can change that one. Well, that's a very comprehensive but mighty complicated tube tester here. When you get the hang of it, it goes much faster, but still. However, we only have gotten the basic gain measurement working. Continuity does not appear to work, and it has many other modes like emission testing, leakage and voltage regulation, which won't work as expected and will send us back into the noodly entrails of this machine. At least we will be rewarded with beautiful glowing tubes. To be continued in the next episode.